So it's nearly to good afternoon. So welcome back to the class on tribology. Right. So if you remember in the previous class, we were discussing about the different type of available bearing materials. Like we dealt about cadmium based alloys, aluminium based alloys, copper based, silver based, and also we discussed about the non metallic bearing materials which are available and feasible to use for making any new designs in bearings, right? So we dealt about all these type of materials, its properties, so how good it is for which type of lubricant, for which type of bearings, all those stuffs we discussed. And coming to non-metallic, we spoke about Teflon and nylon. So wherein the Teflon had comparatively better results for a bearing material in comparison to nylon, right? And also we dealt about the basic properties which has to be in any bearing material. So these guidelines will help you in selecting the bearing material. So regarding what is the general requirement in any material what you select, the minimum requirement, the physical properties which has to be there in the bearing material we dealt about, right? And also we spoke like how to figure out the advantages and disadvantages of any bearing material. We just focused for plain bearing, wherein you can try to enhance the advantages and disadvantages for any bearing material, right? So that I will be giving as a part of your assignment after completion of this module. So then we spoke about what is surface engineering actually, what is the importance of it. So with the help of surface engineering, how we can protect the wear and tear, right, which comes into picture when you have any bearing device or any other moving or rolling component which is coming across in contact with respect to the relative motion, right? Also we studied about why surface engineering is basically needed, and what were the previous techniques and what are the now advanced version of surface engineering schemes which are coming into picture. So I had told you just the basic classification of surface coating process. So these techniques of coating came very recently, but in very tradition practice also people safeguarded the surface of any device from the external surroundings so that it has to be protected from corrosion and many other circumstances. So they used to do it in traditional way, and now as the technology got advanced, we have the advanced way of protecting the surface of any device, right? So these things now you have to study in depth. So as I told you in the previous class, under tradition we have very few techniques which are painting, electroplating, galvanizing, and as well as thermal and plasma spraying. So these are the techniques which come into under traditional categories. So apart from that, we have the advanced coating technologies, what we have to go in depth, right? So this we have to go one by one. So the first one is related to painting. So as the name itself suggests, any product it could be. So if you apply a layer of painting, it will help to safeguard your body across the surface for a long period of time. So it depends upon which type of painting you're basically using. So this is a normal thing what everyone knows to protect the surface of the media. It could be a wall or any other surface of a product what you have to safeguard from the external surrounding. So it depends upon the quality of the paint what you use basically. So basic media to apply a paint on the surface is, you know, it is an brush. So apart from that, you can use a sponge or air brushes which helps in brushing out the thickness of the layer of the paint as requirement, right? So this is the traditional way of safeguarding the surface which acts like a coating layer so that it won't cause any hamper for the surface of the device which you want to use for a longer run. Okay, so when you apply a painting, to the surface, it can use some supporting media. Right, so to apply a paint on the surface, you need a supporting media like an wall, a paper, or a glass, or a wood, right, or an concrete on which you apply a layer of paint so that it safeguards the surface of the concrete for a longer period of time. Because when you have buildings of huge stories which are constructed by using concrete bricks, right? So it cannot be thrown out to the external environment without any painting. It has to be covered with n number of layers of painting. Before that, the plastering has to be done. Then you will apply the type of paint what you need based upon the amount of money you can fetch in, so that at least for minimum around 75 to 80 years you can protect the surface of the building, right, from the external effects. It could be either moisture or any other type of external things which can hamper the surface of the building. It can also result in crack and penetration and also the huge damages to it. So this is a traditional way of support of protecting the devices by means of painting. So the second technique that under the traditional one is nothing but the electroplating. So as the name itself suggests, electroplating, it is a process wherein it uses the electrical current. So when you use an electrical current, what happens is it helps to dissolve some cations. So we are mainly speaking about the metal cations. So when these metal cations are dissolved, this dissolved metal cations results in the formation of an coating across the electrode. Okay, so if you use an electrode, right, so it helps in, so this is electroplating thing. So where you will be having a container in which you will be having the silver nitrate solution. So you will be having an anode and a cathode. So when you have the silver nitrate solution, when you subject an electrical current, so what happens is the cations which are there in the solution will get dissolved and it gets plated on the electrode here, so that it helps in protecting the electrode from the external environment. So here the anode you are using as a pure silver. So this is just an example to explain how a surface could be coated by means of different techniques. So the first one what we studied was related to painting, and this is of electroplating. Electroplating. So this electroplating, you should think when to use. It is mainly used to change the properties of the surface. Sometimes it is like you need to protect the surface from the external surroundings. Sometimes the properties across the surface should be different than that of the bulk body. So to enhance the surface properties, it is essential to have electroplating. Rather than go for protecting, to enhance the properties in any application or devices, you can go with electroplating. Right? Since you deposit a layer here by means of subjecting the electric current and dissolving the cations and applying a film on it, it is called as electrodeposition. The deposition of the cations is happening by means of an electric current, and hence the name it is like electrodeposition. So this is the second method of applying a layer on a device. So one thumb rule is we usually apply a layer on a device in the form of a coating to protect from the external surrounding. The second thumb rule is you will apply a coating on the surface of a device in order to enhance the properties of that particular bulk device, right? So this is the second thing. So based on the requirement, you should think whether you have to go for painting or an electroplating. So these are the very traditional things which are being followed. And the third one here is nothing but the galvanizing. It is also a process wherein you apply a layer of coating in order to protect from the external surrounding. So this galvanizing is basically done in order to protect the materials from the external surroundings so that it won't easily get rusted out. So the components which are highly reactive for the oxygen content in the atmosphere, it gets usually rusted up. So to prevent these rusting features, you can go for galvanizing. So in this process, mainly what happens is you will apply a coat of zinc to the steel or an iron which has a tendency to get rusted when it is subjected to the atmosphere. right? So this is the need. So based on the need, you have to opt for coating. So what is the most common method is like hot dip galvanization. You will dip the steel or the iron in an given media so that it gets resulted in the formation of an zinc coating. So I will explain how the process comes into picture. So if you go for the image here, right? So here you can see the galvanizing process. So you'll be having different steps what you need to follow. So first you have to do the surface preparation and then the drying of the surface, and then it will be dipped in the bath of zinc so that a coating of the zinc will be done across the surface of either the steel or the iron so that it will not get rusted easily when it is subjected to the external surrounding. So this is a thing which usually happens in an galvanizing process. Okay, so if you go into the galvanizing process, basically you will be having two ways to make this layer of zinc coating. The first one is it forms a coating of corrosion resistance so that when you apply a zinc coating on the surface, it shows that it is providing the resistance to all the type of corrosion which can come into picture across surface of the material. So this happens if the material or the metal what you are using is very delicate and it has ease to get corrosion or corroded easily. So again it depends upon the material what you are using. If the metal or the material what you have selected is not is very good and it won't have any problem related to the corrosion, if it has a highly corrosive resistance material, so then no need of going for zinc coating, right? So it has ease for high resistance towards corrosion. Suppose if the metal what you have used is very delicate and it can easily get corroded, so this galvanizing process will help in protecting the surface against the corrosion. So this is the need why the galvanizing has to come into picture. And secondly, what happens is it can also serve as a sacrificial anode. So when you apply a zinc coat on a device, either a steel or an iron, it acts as a sacrificial layer. So that sacrificial layer will help to safeguard the actual bulk of the body. So anything which happens will happen to the sacrificial layer, which claims itself as an anode. So that the object what you have, the device what you have below that sacrificial layer will be safeguarded so that it won't get corroded or it won't get rusted easily. So these are the two reasons why galvanizing has to come into picture. So these are the two things what you have to remember when you need to speak about the galvanizing process. So first you will clean the surface, then you will rinse it. So after rinsing, you have to do an process called as an pickling. So once the pickling is done, again you will re-rinse it. So once it is rinsed, you will dip that into an solution. So once you dip into that solution, so all the impurities which is there will be removed, so totally it will be contamination free. So then you will allow it for drying. So once it is dried out, you have a bath, you have a container which has a zinc solution in it. So you will dip in the zinc bath as per the time required in the dwell time. So once it has been dipped and soaked for a required time period, it will be allowed for solidification and cooling so that the coating which has been applied on the steel or the iron which gets easily rusted will be solidified when it is subjected to cooling. So after cooling, you will inspect whether the coating has been applied uniformly throughout the given rod of steel or iron. So if it is done, so then the steel or the rod, which is the steel or the iron rod, which has been coated with the zinc, will be having an resistance towards rusting, and even it will not get corroded easily. So this is the main requirement why you have to go for galvanizing. So depending upon the requirement, you should think about which process you will opt for to protect your device from the external environment. So based on that, you should think whether you need a painting for the surface or you need an electroplating to enhance the properties of the surface of a device, or you need to protect your device from the external environment, mainly due to corrosion or due to rusting. So based on this, you can find different type of coating. Okay, so this is the thing what you have to do. So finally, the main thing what I forgot to tell you is I told you that you need to dip in the zinc bath for a particular dwell period of time, right? So related to that, if you just go for an example of coating iron and steel, either iron rod or steel rod with the zinc, so what happens exactly when you immerse that in the zinc bath? Okay, so the solution of the molten zinc, what you have in this zinc bath will be at an temperature around 840 degrees Fahrenheit or 449 degrees Celsius. So you will immerse the steel rod or the iron rod in this molten zinc bath, which is set at a temperature of 449 degrees Celsius. Okay, so then you will soak for the required time period. You need to again check what is the dwelling time which has been needed. So if you go into the research papers, it will tell you which is the optimized dwelling period for which you need to soak in. So as per that, if you soak it, it will be equally coated across all the surface of the steel iron rod, so that this could be widely used for any applications without any step back thinking that it can be easily corroded or not. It will be safeguarded because it has a total coating across it. Okay, so in terms of life cycle, you can rely on that steel or iron rod for a longer period of time because it has been coated with a zinc coating so that it won't get rusted easily when it is exposed to the external surrounding. And as the life cycle of that particular steel or iron rod will be enhanced. And also the cost will not be too high, so it will be economical, right? So this is the way how you have to safeguard the device what you have made in, and how to figure out whether it is coated properly or not. If you just subject the sample under FESEM, it provides you the morphology of the surface. Across the surface, how the morphology is. What is the layer of coating which has been done? So what is the crystallization parameters of those pattern which has been developed across the surface could be analyzed right from the X-ray diffraction data, also the morphological data. So this could be identified. So under morphology, if you see, if you don't have uniform coatings, the pattern what you see across the surface in the microscope will identify whether the coating is done properly or not. If it is not done, again you have to redo it. So it is always better to do in a proper way so that you have a uniform thickness of the coating across the surface. So this is just the importance of galvanizing process, why you need to do it. Any doubts until now related to the traditional process which has been carried out? Is it clear enough? Hello, hello, need a reply. Are you people there? Hello. Mr. Vidyan Prakash, are you there? If you don't
Yes,
give me
ma'am.
a reply, how will I come to
Yes,
know?
ma'am.
Are you people understanding?
Yes, ma'am.
Be louder. Are you sleeping? Yeah, awake.
No, ma'am.
So kindly reply properly and listen to the classes. So next traditional technique is nothing but the thermal and the plasma spraying. So here as the name itself suggests, so you will have a thermal spraying technique, so which will provide the required coating process. But when and how you need a thermal and plasma spraying technique, so that you have to understand. So in case of thermal spraying technique, what happens is you get the required coating. So when you heat a material and spray to the surface, so when you heat a material, it gets melted and that melted layer will act as a coating. So it will be sprayed across the surface so that the surface could be protected. So this is the main concept behind the thermal or the plasma spraying technique. Right, so here in this case, you will be having a feedstock. So this is called as a coating precursor. So the coating precursor, which is there in the plasma spray technique, will be heated with the help of a plasma arc. So when you make the plasma spray technique on, so you'll be having a plasma arc. So this plasma arc will result in getting the required chemical process. Okay, so what happens here is the feedstock will be heated. So when it heated, the chemical reaction which comes into picture will result in the formation of a combustion flame. So this is nothing but the combustion flame. Okay, so now due to this combustion flame, what happens is the spraying, the thermal spraying which is coming due to the combustion process will deposit on the substrate. So this will be the substrate which has to be safeguarded. So when you have this combustion flame coming out due to the chemical process wherein the plasma arc is being resulted by the heating. Okay, so this gets deposited across the surface and it results in the formation of an coating. So this coating is similar to that of electroplating, what we have studied earlier, and also the chemical vapor deposition, which is the higher end technique, also use the same phenomena. Okay, so this is a way how an thermal spraying or a plasma spraying process comes into picture. So for a thermal spraying or a plasma spraying, by default you should be having an anode and a cathode, right? So you'll be having an precursor here which will be used. So when you subject the electrical current, so what happens, the precursor will get reacted with respect to the anode and the cathode. It results in the formation of an arc. So when the arc is formed, it results in the chemical process. Due to this, the combustion of the flame comes into picture. So this combustion of the flame will help in making the deposition across the surface of the substrate. So this results in the formation of an coating layer. So which are the coating materials which are being used? You have to think about. So these are a combination of alloys, ceramics, plastics, and composites. So the precursor or the powder what we'll be using here for the coating will be either the combination of alloys, or it could be ceramics, or it could be plastics, or it could be composites. So when we tell about the composites, again it is combination of more than one material, or it could be plastic, or different categories of ceramics, or combination of metal and its alloys, right? So based on the requirement for which you are going for coating, so based on that you have to select the precursor or the powder properly. So with the help of the plasma arc, this powder gets reacted in the chemical process. So once the chemical process is done, a combustion flame will be developed. So this is the combustion flame what you get due to the chemical process. So this helps in creating the layer of the powder what you are using as a deposition layer. So this deposition layer will help in protecting the surface from the external surrounding. So this happens in case of thermal and plasma spray. So if you go specifically to an plasma spray, exactly, so what happens in plasma spray is you will be having the powder in the sense it will be any material what you are selecting, either the combination of alloys, ceramics, plastics, or composites. Okay, so this powder will be fed either in the material will be either fed in the form of powder or in the wire form. Okay, so then it will be heated to an molten state. You should be knowing what is the molten temperature of the material what you are using. So you will get started heating this material to the molten temperature. So when you get heated at the molten temperature, the material gets accelerated. Okay, so that gets accelerated. Why? Because due to the chemical process. So when the material get accelerated, it moves from one end to the other. So finally you have a substrate here. It will come and deposit. Okay, so it can happen with respect to temperature effect, or it can happen due to the plasma spraying. So in both the case, it helps to deposit the coating across the substrate. So this is the way how a plasma spray technique could be used. So this plasma spray technique is very useful when you're going to make a micro device, which is micro electromechanical systems. Okay, so to make any MEMS device, usually the plasma spray deposition will be very much useful. But only one thing is it has one disadvantage. What is it? Is the plasma spray process is very expensive as the cost is comparatively higher, and even the complexity which is there in the process is also a little bit more, and hence even though it is a very good technique, these two disadvantages will think about whether to go with plasma spray or not. If any suggestions and modifications could be done, then you can think about going plasma spray technique for a large area of application. So this is about the plasma spray. So until now we discussed about the traditional type of coating. So what were the traditional type of coating? To protect the surface from the external environment. So one was painting, electroplating, galvanizing, the thermal and the plasma spraying. So this is a traditional one. So then comes into the advanced coating technologies, what we can apply as per the requirement. So these are physical vapor deposition, chemical vapor deposition, ion implantation, ion beam assisted deposition, how to make ion beam mixing, and laser treatment. So these things you have to now go one by one. So before that, let me just talk about the outlet layout about different surface coating methods. So when it comes to surface coating methods, these are the methods which are followed in any clean room when you want to make a micro or a nano device. Okay, so these are the basic requirement one has to follow when you want to go for MMs or a nano device fabrication. So wherein you use complex type of coatings. So this coatings could be categorized into three sections. So what are these three sections? Basically, it is like gaseous state, solution state, and it could be semi-molten state. So we have three techniques. So when you go for gaseous state, so how you do the coating? It is by three process. So one is CVD, PVD, and IBAD. So all these three are the way of applying the coating to the surface by the plasma variants, right? And hence the name CVD, PVD, and IBAD. So in your syllabus, you have CVD and PVD, what we will be dealing one by one. So when it comes for solution state type of coating, we have different methods to apply the coating across the surface. So this also we usually go up for thin film. So whenever you have made a thin film and you want to make a coating on it, you have to go by means of solution state. So what are the three variants available under solution state? One is the chemical solution deposition. By means of chemical solution, you deposit a layer of coating. The second one is you will embed the chemical deposition with the help of an electro circuitry phenomena, and hence this electrochemical deposition. So the chemicals will be deposited on the surface to safeguard from the external surrounding with the help of an electrical media, and hence the name electrochemical deposition. The last method is a sol gel process. So it is a very commonly and frequently used process in thin film to apply a coating on it. It is called as a sol gel process. So you will be having a liquid of specific viscosity, right? So it will be allowed to turn under some RPM, sometimes subjected to high temperature or in room temperature, and it will help in assisting creating the required coating on the surface. So these are the three methods which are available under solution state. So under that, if you go for chemical solution deposition, we have three specific sub-classification. How these chemicals are deposited. It could be deposited by reduction in the chemical quantity. So when you reduce the amount of chemical quantity from the chemical solution, the reduced amount of chemical will be sprayed across the surface and it results in the formation of an coating layer. Second one is electroless deposition. So how you do the deposition of the material without using the electro part. So that is nothing but the electroless deposition using chemicals. Next is chemical conversion. So you are using a technique in such a way that the available chemical will be converted into the required subclassifications, and in that one variant will be used to deposit on the substrate. So this is like having a chemical conversion from the available chemical solution. So these are the three variants which comes into picture under chemical solution deposition. And the last one is the semi-molten state. It will be neither in gaseous state, neither in the solution state. It is like semi-molten state. So here you will directly throw the layer of coating by means of spray technique or by means of laser spraying or thermal spraying. Okay, so again it is related to the plasma variants here. So one is in gaseous state and another one is in semi-molten state. So this is also having the plasma variants. So this is a huge classification of surface coating, what one can follow in this latest trend in order to protect the surface of any product from the external surrounding, so that the life of the product will increase, and also you can rely on that product for its performance for a longer period of time. If surface coating is not done properly, so then you will face many problems and the product can be easily put into scrap with a shorter life cycle. So this is the importance and need why a surface coating is very much essential for any device what you have to run for a longer period of time. So this is the importance of surface coating methods. So after this, hope any doubts related to surface coating classification? Is the things clear enough? Hello, Mr. Kiran, are you there? Subramanya, kindly give a reply.
Yes, ma'am.
Are you understanding? Hello,
Yes, ma'am.
any doubts, please let me know. So under surface coating technique, you now have to study about the physical vapor deposition. So what happens in physical vapor deposition? So here a layer of coating will be deposited on the substrate with the help of vacuum deposition technique. So you should understand what is this vacuum deposition method. Right, the substrate will be kept in an closed vacuum chamber and you will be having the variants of vapor which is coming and falling on the substrate, and it gets in the formation of a thin film, right? So this is the main trend which has been followed in physical vapor deposition. So how you get this layer of vapor deposited on the surface so that you can characterize it by going into the morphology of the material and see whether the layer deposited is uniformly done across the surface, is the thin film uh, coating is done properly or not. So this you have to cross check. First you will do the layer of deposition, then you will cross check by seeing the characterization of the layer which has been deposited. Okay, so in case of physical vapor deposition, you have two techniques through which the layer of vapor has been deposited. So what are those two layers? What are those two processes? One is the sputtering and the evaporation. So you can have a layer of vapor deposited on the substrate either by sputtering unit or by evaporation. Okay, so you have to understand how now the vapor deposition is being done. So if you think about either sputtering or the evaporation process, so you have to see that both the sputtering and the evaporation has different components. Okay, so these components will help to produce the required vapor phase. So once the vapor phase has been developed, it could be easily deposited on the surface. Okay, so in case of vapor phase, what will happen is the supersaturation, the vapor which comes to has to be in supersaturation state. It is not in saturation. First it gets melted, the vapor comes out, so then it will be saturated, the vapor will be saturated, then still the temperature should be enhanced such that it goes for supersaturation level. So when it is at supersaturation level, it is purely in vapor phase. So this supersaturated gases will be deposited on the surface to get the required coating. Usually this process will be followed when you want to deposit a very thin nanomaterials across the surface to protect it for a longer period of time. Okay, so to do this, usually we go with using the nano composites. So this nano composites will be subjected to the heat treatment. So you have to check what is the melting point of these composite materials what you are using. So what is the upper limit to which the temperature could be enhanced so that the composites what you're using will reach the supersaturation state, and once it is in the vapor phase it gets deposited on the substrate. Okay, so all these has to be done under an controlled atmosphere which is called as an inert atmosphere. You cannot do that in an open air. Okay, so this is the glimpse of how the vapor deposition process could be carried out. Okay, so suppose if you see a diagram over here, you will be having a vessel, a container which has a base material, right? So when you subject the temperature, when you when you subject an heat treatment to it, based on the melting point of the base material, it gets heated up, right? So it converts it melts and the vapors comes out. So you have to heat until the super saturated vapor is coming out. So this supersaturated vapor which is coming out will help in forming a coating on the substrate material. So you'll be having an holder which holds the substrate. So the vapors which is coming out from the base material when it is subjected to heat treatment will result in the formation of the coating layer over here. Okay, so this way of coating could be done either due to physical vapor deposition or by chemical vapor deposition also. So if it is a chemical vapor deposition, a chemical reaction comes into picture. So that we will study little bit later. So this entire thing has to be done within an inert atmosphere, means in a controlled atmosphere condition. You cannot do this in an open air theater. So this is the importance of PVD, which is nothing but the physical vapor deposition technique. So if you want to still go in clear enough, so you can see that it has to be done in inert atmosphere, means it should be done in a closed environment. So wherein you won't be having an open atmosphere. Okay, so here this is the closed inert atmospheric controlled condition in which you will be having an holder which will hold the substrate, right? So here you will be so okay, this is shown in a reverse way, fine. So this is the container which holds the target material. So the target material will be nothing but the base material what I told. It could be like combination of any composite materials. So the material which has to be deposited will be claimed to be as a target. So you have to be very keen in selecting the target material. So that target material should safeguard the substrate from the external surrounding. The substrate is nothing but the base surface of the device what you have made. So across the top of the base device you have to protect by making a coating layer. So that will be done with the help of the target material. So the target material is the coating material what you will be using. So you will connect to this to an circuitry system, right? So when you make this a sputtering unit is subjected to a high temperature, the target material gets melted, it gets vaporized. So you will increase the temperature until and unless the material what you're using gets vaporized. So this vaporized material will come and drop on the substrate uniformly. Okay, so it results in the formation of an thin film. So this happens when you have an inert atmosphere. Okay, so you have to sputter the gas through this direction. Okay, so with the help of the sputtering gas, the melted vaporized target material will easily come and fall into the substrate, resulting in the formation of a thin film. So this is how it works in developing a coating across the surface what you have developed. So always the material what you use to apply the coating will be called as a target, and the material what you have developed on which you need a coating will be nothing but the substrate. So this will be very keen if you just focus on thin film fabrication. In that, this PVD technique plays a really vital role. For the regular coating, the traditional one, what we studied earlier, like painting, the plasma ray, the electroplating, galvanizing will hold good. But when, as in now, the device will be thinner and thinner into micro and nano level, this type of PVD coating and CVD coating will play a very vital role. So when we speak about the thin film, it is usually the target and the substrate, and hence in the PVD coating, it is usually mentioned as the target and the substrate. So you should not get confused what is the target and what is the substrate material. So this is about the PVD technique. And now next we need to go for CVD as well. So these are different products which are being coated with the help of either CVD or PVD techniques. Okay, so we will go further. And one more thing, I told you that the layer could be deposited by means of vapor phase or by sputtering. If it is sputtering, so how it will be sputtered? It could be sputtered either by ion beam sputtering or it could be done by magnetron sputtering. So here what happens is it helps to sputter the layer of coating from one point to another. So all this also happens again in a controlled atmosphere, okay, in an inert atmosphere. So wherein it helps to move the atom from one point to the another, and it results in the formation of the film. So as you have the bombardment of the atom from one location to the other, so it is moving from one end to the other and resulting in the required coating. So this will happen in case of magneto sputtering. So in ion beam sputtering, so you will have the source of material which fall from both the direction and it gets sputtered across the surface and results in the formation of an coating. So this happens in case of ion beam sputtering. Okay, so this is about the thermal evaporation. So with respect to the heat effect, so the vapored phase of the target material will come and fall into the substrate and result in the formation of required coating. So all these phenomena will need a circuitry system. So with the help of that, the coating could be done. So this is in glimpse about the PVD techniques which is being used. So once you're thorough with the PVD techniques, you can see that we have different classifications under that. One is the evaporative PVD and the other one is the sputtering PVD. So if you go for evaporative PVD, you have different variants. You don't have so much in depth to study each in depth, but you should be knowing how it has been classified and how it works at least. Okay, so evaporative PVD, you have a resistive type, inductive type of PVD, electro beam gun type of PVD, arc based PVD, and laser based PVD. And when you go for a sputtering unit for a PVD, you have four classifications. One is the diode based, magnetron based, ion beam, and triode based of PVD technique. So these are the things you should be knowing how to classify. In general, I'm telling you, you should know some informations. Okay, so evaporative PVD, you have like three variants, what I'm telling you. So one is the EB evaporative PVD. So this is a thermal evaporative and this is a laser evaporation technique what you have in general. If you go in general to sputtering deposition, right? So you have two types. So one is the magnetron type of sputtering. So what happens in this sputtering unit is you will be supplying the voltage to the given container. Okay, so you'll be having a voltage what you apply across the rarefied gas. So it will be an vacuum chamber. So you'll be having an inert atmosphere with the required gas. So you will subject the voltage to the rarefied gas. So what happens is a breakdown occurs in the gas which is there in the closed chamber. So due to the breakdown of the gas, it results in discharging the plasmas. So these plasmas will be having negligible mass. Okay, it will not be having a larger mass. So the mass of the plasmas could be neglected. So when the plasmas will come down due to the breakdown of the gases, a positive ion also comes out from the plasma. Right, so this positive ions which is coming out from the plasma will strike against the negative electrodes. So you have the positive charge and the negative electrodes. So when these two gets strike enough, and some amount of energy will be generated. So the amount of energy which is being generated will be transformed to the targeted atoms. Okay, so when it transforms to the targeted atoms, the few of it will escape and directly come and sputter uniformly on the substrate. So when it sputter, it results in the formation of thin film. Okay, so this is about how when sputtering comes into picture. The same sputtering phenomena could be done by means of magnetron. So here, instead of using an gas, you will be using a magnetic field. So you will be having the magnets with north and south pole, north and south pole. So this magnetic field helps in bombarding the electrons, and those electrons will be deposited on the layer of the substrate, and hence the required coating will be done. So one thing is due to the breakdown of the gases with the subjection of the electrical field. The other one is due to the magnetic field which is generated by the magnets what you are using, and bombardment of the electrons and deposition of these electrons on the surface of the target material. So this is the target material, so the coating will happen here. Okay, so this is how it helps in getting the required sputtering depositions. In your syllabus you have just PVD, this one polymer physical vapor deposition, which is the PVD technique. So if they ask you the PVD technique, you should be able to know how this process comes into picture. One is due to the sputtering, and other one is due to the evaporation. So both the techniques I have explained you, and how the supersaturated vapor phase comes and how it will be deposited, you should explain. Okay, so then classification, you can just tell which are the variants you have, and only speak in general about the evaporation technique and about the sputtering technique, as I told you about the evaporation as well as the sputtering technique. If you can draw a simple line diagram and explain also, it will be really helpful. Okay, so this is just an mechanism of sputtering techniques. Okay, suppose you have the surface of the substrate and you have an atom or an ion which is coming and striking the surface with some kinetic energy. So then it results in bombardment and the ejection of the ions or the atoms. So these atoms will move from one end to the other, and this continues from one end to the other as shown in the diagram over here, and this results in forming and coating across the surface. So this is nothing but the sputtering mechanism, as I explained you before. Okay, the same technique will happen here. It depends upon whether the gas has been used to bombard, or a magnetic field is used to bombard the electrons and just have the coating across the surface. So this is about the PVD technique. Any doubt related to physical vapor deposition technique? Is the things clear enough?
Yes, ma'am.
Okay, so next is the chemical vapor deposition technique, which is called as an CVD. So what happens basically in chemical vapor deposition technique? It is a process basically you use wherein you will be having n number of gaseous species. So it will be like applying a chemical inert media in which you will allow this gaseous species to pass in and get the required chemical reaction. And due to the chemical reaction, what happens is you will subject that to the thermal variance, and this will result in activating the gaseous species thermally. And due to this, the plasmas will be generated, and this plasmas will be having the positive ions also. So these positive ion charges will get accumulated across the surface, and it results in the formation of the required coating. So this is the way how an coating comes into picture in case of CVD. In case of PVD, you will be having the sputtering mechanism as well as the evaporation technique. Whereas in case of CVD, you will be having an gaseous species wherein you will result in forming the required chemical reaction by means of subjecting the temperature effects, wherein it helps in releasing of the plasma. Once the plasmas are released, it has negligible mass with positive ions. These gets deposited on the substrate, and it results in the formation of an film. Suppose if this is a substrate, you will result in the formation of an diamond film. So it depends upon which is the target material you are using. Okay, so it helps, the plasma helps to throw the layer of diamond film here, and you will subject what is the melting point so that it melts and gets deposited over the substrate. So this is way how it happens. So before going into depth, let us go through the classification part of it. So in case of chemical vapor deposition technique, we have different classifications. Okay, so this can be done in an very normal pressure, or it could be subjected to the low pressure, because everywhere in chemical vapor deposition we will be using a gaseous species. So the gaseous species what we use could be in a normal pressure or it could be in a low pressure. If you are using the gaseous species in low pressure, we have two variants again. One is the plasma assisted and the automatic layer epitaxy. Okay, so in both the things you have different type of depositions. One is a DC plasma, pulse plasma, AC plasma, RF plasma. Usually in thin film deposition they go for RF plasma magnetron. This is most commonly used type. Okay, so usually they perform at low pressure only. And last one is microwave plasma. This is also now recently been started. This is the second version of deposition. And the third will not be related to pressure, it will be related to the electrons. So with respect to the electron assisted, the deposition comes into picture when you enhance the temperature of the electron. Okay, so next is laser assisted. So the laser assisted beam of coating will be applied. So next you might be applying a layer of coating due to hot filament. So you'll be using a filament and you will enhance the temperature of it so that the plasma which comes out through the hot filament will be deposited on the substrate. And sometimes you can use an organic material, a metal of an organic one, to apply as a coating layer on the surface. Here also you should subject this to the heat treatment so that it helps in vaporizing the organic metal and forming an epitaxial layer on the surface of the substrate. So this helps in making a coating. And lastly, chemical vapor infiltration. So this is creating a chemical chamber for the reaction of the gaseous species, resulting in the formation of plasma and making those deposition of the plasma positive ions on the substrate. So these are the different variants of CVD techniques which are available to apply a layer of coating across the surface. So this is about the materials which are being used as a target for PVD. So most commonly used PVD materials are titanium nitrate, zirconium nitrate, chromium nitrate, titanium aluminum nitrate. So whenever you go with titanium based alloys, it is an expensive one. So the target material purchasing itself will become expensive. So based on the requirement, you should see that which is the target material you are using to apply and coating. So this type of coating is very much needed in industrial applications, right? So if it is for industrial applications, the coating what you have to use should be very accurate, precise, and to be relayed on it for a longer period of time. And hence it is very much essential to select the target material properly. Okay, and these are usually expensive, but still it is very much mandatory to safeguard the device what you have developed across the surface from the external surrounding. In that case, going up with this target material is very much essential. So these are the advanced coating technologies which are available under PVD section. Okay, so this you should be knowing enough. It is not like only you know the process of PVD and CVD, which are the type of materials which are used, what are the tools used for fabrication, all things you should be very much clear enough. And where you go with this advanced coating technology is you can understand with a simple example. Suppose you have made a semiconductor device. Okay, so this semiconductor could be a micro MEMS device or a regular device. So this type of device will be developed by using solar panels, and the solar panels basically will be thin films. Okay, so how you will protect this thin film solar panels? You should be having some coating across it. we usually go for coating where the devices are at micro and nano level. You cannot protect that from the open atmosphere. It should be either kept in a desiccator so that it is not open up to an atmosphere frequently, or it has to be safeguarded by making the coating layer. So in this case of application, developing a coating layer by using good suitable target material as mentioned here is very much essential. And second, wherein if you want to protect the food from the external environment so that the food has to be kept fresh for a long period of time. So also you need a thin coating across the packaging of the food so that it supports, so that it protects the food and retain that as fresh when you have a proper coating across it. So these are the needs where you want a very thin film of coating which could be applied by PVD techniques. So the costly materials are as usual as I told, nitranium based, titanium based nitrate, zirconium nitrate, chromium nitrate and titanium aluminum nitrate. So this is about the coating technologies and the materials which are available for different applications. And we were telling about the chemical vapor deposition technique, why it is being used. Here we mainly use the gaseous species. So in inert chamber, by varying the thermal parameters, plasmas will be generated and that will be deposited. So how exactly you should be knowing clearly, right? So what thing you have to understand is the CVD, which is nothing but chemical vapor deposition, as the name itself suggests, is a chemical process. So where you use this, so this deposition you use where you need an high performance of any device what you have developed. So this devices what we develop will be made in bulk by using solid materials. So this should be safeguarded for a longer period of time, means you need a good coating layer on it. So in that case, you can go with chemical vapor deposition. So next question which comes into mind is, okay, you know about chemical vapor deposition, but in which type of industry it is basically used? So the second answer is this type of a chemical vapor deposition is usually being done in industries like semiconductor industries, because in all the semiconductor industries basically they develop the thin films. So protecting the thin films from the external environment is very a bigger task. So you should have a good coating layer. So this good coating layer which can relay for a longer period of time could be achieved by CVD process. So this is like 99.9% applications are used in our semiconductor industries. Okay, so here you should be very keen in selecting the substrate. The substrate is also called as a wafer. Okay, so the wafer or the substrate will be exposed to one or more volatile precursors, because the substrate what you have developed, you have to see that how it reacts for the external environment. So the how it affects, you can check into when you use some volatile materials which can show sudden response to the external environment. So these you will select which are the volatile materials. So that will be the precursors. So then you will check the reaction of this precursors when it deposited across the surface. So you will deposit this frequently and check the variation of volatility with respect to the product what you have produced. So you can see how the variation is coming into picture. So by trial and error, by analysis, you can select which is the best precursor so that it helps in protecting your substrate from the external surrounding. So here this will be like a closed chamber. You will be having what we say the substrate, and you will embed the wafers on it. Okay, so what happens is you will be having an heater which helps in passing the temperature through it, so that what happens is when you expose these substrates to the volatile and volatile precursors, so it results in forming some chemical reaction. Some might cause some damage to the substrate, or some can protect the surface from the damages. So you will select which are the volatile precursors which damage the substrate, and which are the precursors which will not damage the surface. So based on that, you can select the type of the precursors which are volatile in nature. So how to protect the substrate from those volatile materials, so that you will analyze by varying the temperature, by varying the amount of gas which is passed through the inlet material. Okay, so the gas you will be allowed to pass through the closed chamber, right? When you subject the heat, the gas can compress and expand. So based on it, you will be having the variation in the pressure. So that variation in the pressure will be recorded by the pressure sensor here. So due to this variation, the wafers what you have will get affected, and it shows the variation from one end to the other. So then you will check what is the volatility which is coming across the wafers. So all these things takes place within the closed inert chamber. Okay, so this is the process what they do, trial and error, and select the best volatile precursor, and see that how you can overcome the volatility of this material. So this is the in general process what they perform. So when you go with this, you can use the materials which are in crystalline form, which are in monocrystalline form, which are amorphous material, and it is also you can focus on epitaxial material. So these are the different forms of material crystallography what you can use. So every material could be in a crystalline form, or it could be in a polycrystalline form. Monocrystalline is nothing but the single crystalline structure, okay, or it could be in polycrystalline. So if it is a single crystalline, the variance with respect to its unit crystal structure, its lattice parameters, Miller indices, everything comes into picture. The properties of a polycrystalline material will be different, whereas the properties of an monocrystalline material will be different. It could be like an amorphous material also. So based on the classification of the materials what you use as a volatile precursors, the variants could be analyzed. This is basically purely used in thin film industries only for the semiconductor applications. So this is the example of plasma assisted CVD again here. Okay, so how the deposition comes into picture with respect to plasma enhanced CVD, what we have. So this is the plasma which is coming on, which will be having the positive ions in it. So it will be deposited on the substrate. Time up. Okay, okay. I'm sorry, I didn't see the time. Okay, so this is about the example of plasma assisted CVD. So there are other practices which are being done in day-to-day new trends. Okay, so there are n number of trends of new practices which are coming in combination of PVD and CVD also. So it is like many coating solutions you can get in a single umbrella under one process. So these are different layers of coating what you can do. A different layers of coating, you can get a multi-layered coating also, so that it will really have a permanent safeguard for your surface from the external environment. So these things you should be very much clear enough. So from the next class, we will focus on the other type of techniques, ion implantation, ion sputtering, all those steps are left out. So we will deal with that. Any doubts associated with this, kindly let me know. I didn't see the time, it is 12:59. I'm sorry, I feel I might, you might be feeling hungry. Are the things clear? Everyone type your name and USN in the chat room. Any doubts?
No, ma'am.
So kindly do answer your attendance. Abdul Khalid Pasha is there. I think he is absent. Akhil KV,
Yes, ma'am.
Anil Kumar,
Present, ma'am.
Ankesh Aman,
Yes, ma'am.
Gautam Krishna. Gautam Krishna is absent. Balaji VR, absent. Beldar Mohammed, Chaitanya SR,
Present, ma'am.
Chetan Kumar, Chetan Kumar, absent. Dheeraj, Ishant, Arshit,
Yes, ma'am.
Himanka,
Present, ma'am.
okay. Kanishka,
Yes, ma'am.
Nagamurli Krishna, Nagamurli Krishna is absent. Kunal Raj, Kunal, absent. Danush, Mohammad Ayan, absent. Mohammad Junaid is also absent. Shri Prasad,
Yes, ma'am.
Niharika,
Present, ma'am.
Nihar Venkatsai,
Yes, ma'am.
Nikhil,
Yes, ma'am.
Nirav,
Yes, ma'am.
Prajwal, absent. Rishabh Pandey,
Present, ma'am.
Rohan Kaglakar, Rohan, Roshan Yadav, Roshan, Sumant Sagar,
Present, ma'am.
Sagar Dutt Mathur, absent. Sagar GV,
Present, ma'am.
Sanjay Raghav, absent. Shobit,
Present, ma'am.
Siddharth, B, Siddharth Sridhar, I think both are absent. Subramanya,
Present, ma'am.
Tirumana Sethi Rohan, absent. Ulas,
Present, ma'am.
okay. Vidyan Prakash,
Present, ma'am.
Varun.
Yeah, ma'am.
Yeah, did you submit the report, Varun?
I'm just waiting on Abdul, ma'am. He hasn't sent me the details, ma'am.
Okay, do it at the earliest.
Okay, ma'am.
Pawan,
Present, ma'am.
Danush, Danush, Gyanesh Kumar, Gyanesh is absent. Gunasagar,
Present, ma'am.
Meghanatha,
Present, ma'am.
Rasik Baran, Rasik, Shiva Krishna,
Yes, ma'am.
Shreyas, is absent. I don't know what is the problem with him. Is regularly irregular. Srinivasalu, are you there? I'm not able to listen to your voice, but drop a message in the chat room. I'm not able to listen to your voice. Yogananda,
Present, ma'am.
Kiran,
Yes, ma'am.
Ranveer Singh Chauhan, Gautam Sai, absent. Abdul Kalik Pasha, Shiv Pavan, Alok. Fine then, everyone take care. Have a good day. So we'll meet in tomorrow's class.
Thank
Until
you, ma'am.
then, take care. Yeah, bye bye.
Present,
Yeah,
ma'am.
Srinivasalu. Okay.